As a continuation of our look into electrochemistry at the general chemistry level, one of the early skills that you have to adapt to is balance and redox equations in acidic and basic medium. There's a procedure involved. It's kind of tedious if you read it in a list, but if I just show you an example or two, I think it's definitely followable. And whether you have acidic or basic medium, it's very related, the procedure, and it's pretty self-explanatory and intuitive. Acid is easier, so let's take this equation first. We have cyanide, permanganate ion, uh, CNO minus, the name of that escapes me, cyanate maybe, I'm not sure, and then manganese 4 oxide. Okay, so and we're told it's in acidic medium, so that will tell us to click into our acidic rules. First thing you do is you write half equations. A half equation has got nothing to do with a half or 50% or 2. It just means take every species and look at it before as a reactant and after as a product. Okay, so I'm going to call these half equations A and B. So Cn minus clearly goes to give CnO. It's the only source of carbon and nitrogen. And then MnO4 minus clearly goes to give MnO2. So they're my two half equations. Now I need to balance them, and there's a certain hierarchy of balancing. So I would highly advise you to do exquisitely the following, and in this order. You want to balance non-oxygens and hydrogens first. So anything that's not an oxygen or a hydrogen, balance it. So I'll go ahead and I'll use red to indicate things that I'm changing. Everything in black was given to me. Everything in red I'm going to be changing. So I've got carbon on either side, one of them, and I've got a nitrogen on either side. So I've balanced my non-oxygens and hydrogens for half equation A. Repeating for half equation B, I've got manganese on either side. So I've balanced my non-oxygens and hydrogens for half equation B. Next, once you've done that, then you go on to oxygen. You balance oxygen by adding water molecules. I've got an oxygen as a product here, but I have no oxygen here. So I'm going to go ahead and add a water molecule. That's how I add oxygen. So now I've got one oxygen on either side. But notice I've had to add 2 adventitious hydrogen atoms. That's because finally you go in and you balance the hydrogens, and you balance hydrogens with H+, which is just a proton. So I added 2 hydrogens here because I needed the oxygen from water. So I go back and I counterbalance with 2 protons. So now everything is balanced. I balance the non-oxygens and hydrogens first, then I balance the oxygen with water, and then finally I counterbalance the hydrogens with H+. And at this stage, I like to go in and recommend to my students they write mass, and they give it a little check mark so that they know in an assessment, hey, I've gone in and checked the mass. Let's go ahead and repeat here. We already dealt with manganese. I've got 4 oxygen here and only 2 here, so I need an additional 2 oxygen. So I'm going to go in and add 2 water molecules. That gives me 2 oxygen. So I've now balanced the oxygen on both sides, but at the expense of adding 4 hydrogen. So that's okay, I just need to go back over here and counterbalance with 4 protons. So again, I've balanced everything as I should, and I'm going to go ahead, give myself a little check so that I know I've done it. Now you have to go in and balance the charge. Always balance the charge last, so always balance the mass first. Now we balance the charge. The charge doesn't have to be 0, it just has to be equal on both sides. Conservation of charge. I have a negative charge on the left, a negative charge on the right, that's great. But then I have 2 extra positives here. So I need to these are balanced, but I need to get rid of these two. So I'm going to go ahead and add 2 electrons, which are negatively charged. So the 2 electrons mop up those 2 positive charges, and then a negative equals a negative. So my charge C is now balanced. The only thing I can do, again, the charges don't have to be 0, they have to be equal. The only thing I can do to make them equal is to add electrons either as a product or as a reactant. So my first half equation is balanced. Now on to my second half equation. Notice I have no charge on the product side, but I have a negative and 4 positives, so I have net 3 positives. So 3 positives does not equal 0. So I have to go in and get rid of those 3 positives by adding 3 electrons. So now my charge on half equation B is also 0. Or at least it's balanced, sorry. It doesn't have to be 0, it has to be balanced. It has to be the same on both sides. Notice that in half equation B, my electrons are reactants. In half equation A, my electrons are products. What's important is that you have half equations with electrons as reactants and products. You can't have half equations where you only have electrons as reactants or as products. You have to have electrons on either side of the arrow, but they have to be the exact same number, because essentially you don't have a cluster of 2 electrons and a cluster of 3. You have one cluster of electrons and they have to be one number. So we know that 2 and 3 factor into 6. So to make 2 electrons 6, I have to take the whole of half equation A and I have to scale it by 3, which means I take 3 of everything, including the 2 electrons, to give me 6 total. And likewise, to make these electrons equal to those electrons, I have to multiply half equation B by 2. So at this stage, I like to rewrite because otherwise it gets kind of busy. So I recommend writing a line and then just rewrite what you have, multiplying through by coefficients if you have them. So I have 3 Cn minus and 3 lots of water. And I've got 6 electrons. And I've got 8 protons. And I've got 2 permanganates. So I've got 1, 2, 3, 4, 5 reactants because I had 1, 2, 3, 4, 5 reactants. Now my products, don't forget to multiply through by your coefficients. I have 3 CnO minus. 3 multiplied by 2 is 6 protons. 3 multiplied by 2 is 6 electrons. And then finally these two products, I have 2 multiplied by 2 is 4 water molecules. And then finally 2 multiplied by 1, so I have 2 manganese 4 oxides. Okay. So I've got everything, so I deconstructed into half equations, I balanced mass and charge, I reconstructed into a final equation or a recombined equation. It's not final yet. Now we need to go through and cancel spectator ions, so anything that's common to both sides, we want to reduce it down. First thing that you should always do is cancel the electrons. So I've got 6 electrons as a reactant and a product. Electrons should never be in your final expression. Always get rid of your electrons. Okay, so they've gone. I only have cyanide as a reactant. It's not present as a product. This is different because of the presence of oxygen. So you can't get rid of this because clearly they're 2 different chemicals. I have water common to both sides, 3 moles on the left, 4 moles on the product side. So I can subtract 3 moles of water from both sides, and I'm left with 1 net mole of water on the right. I have 8 protons on the left and 6 on the product side, so I can subtract 6 protons from each side. and I'm left with 2 net protons on the reactant side. MnO4 and MnO2 are not the same, so they don't cancel. And I can't reduce these coefficients down because I have a 3 and a 2, and I can't divide through by 2 because then I'd have a fraction, and it's ill-advised to have a fraction in your final answer. So let's go ahead and rewrite our final answer. Nobody wants to see that as a final answer. That's more chicken scratchy. So finally, let's just rewrite. So 3Cn minus and 2 protons over here, and 2 MnO4 minus to give 3CNO minus and 1 water molecule and 2 MnO2. I can't reduce these coefficients down. If I could, I would, but on this occasion they're already reduced down as low as they'll go. Let's go ahead and double check our mass and charge before we sign off on this question. Always check your mass first. I have 3 carbons on either side. I have 3 nitrogens on either side. I have 2 hydrogens on either side. I have 2 manganese. I have 2 multiplied by 4, which is 8 oxygen. I have 3 oxygen here, plus 4, plus 2 by 2 is another 4, so I have 8 oxygen total. So my mass is balanced. Now my charge, I have 3 negative charges, plus an extra 2 negative charges, so I have 5 negative charges. But then I have 2 positives, so I have a net 3 negative charges, and that's matched with 3 negative charges. So I've reduced down as low as I can. I don't have electrons in the final answer. My mass is balanced, my charge is balanced. And this is how you would balance a redox equation in acid. I'll erase the board and we'll do an example in base. Okay, so now we're going to move on to look at balancing a redox equation in a basic medium. And I should point out that a common mistake that some people can make here is they assume that the chemicals themselves are what make the medium acidic or basic. That's not correct. You can have any chemical you like, and an acidic solution can be imposed upon you, or a basic solution can be imposed upon you. So don't think that, you know, if you had something that's naturally basic, it couldn't be balanced in an acidic medium. You could just shower it with acid and then it would be in an acidic medium. So that's something to bear in mind. I picked this as an example because it will often stump you if you've never seen one like this before. I've only got 1 reactant and 2 products, so I'm going to have a lopsided half equation, so it seems. But we're going to try anyway. So we'll go ahead and write our half equations. So we have Br2 is my only reactant. That must be the source of bromate, BrO3 minus. We'll call that half equation A. And then half equation B, well, I have no choice. I've only got 1 reactant, so I'd have to use it again. Br2 now gives bromide, Br minus. So if you ever have what looks like a lopsided equation, you just have to use the same chemical twice for each half equation. So there's no big deal there. We're now going to proceed, as we did with the acidic medium, to balance the non-oxygens, balance the non-oxygens and hydrogens first. So in this case it's bromine. So I have 2 bromines on the reactant side, but only 1 on the product side. So to balance the bromine, I'd have to put a coefficient 2 here. So now I've got 2 bromines on either side. Likewise, I've got 2 bromines here, only 1 here. So I'd put a coefficient 2 here. So now I've got 2 bromines on either side. Now I go in and look at the oxygens next. I've got 2 multiplied by 3, so I've got 6 oxygen. So I'm going to go in here and I'm going to write 6 water molecules. because I can only balance oxygen with a water molecule. So I've got 6 oxygen. I've got now 6 oxygen. But in doing so, I've added 12 hydrogen. So as before, I'm going to go back in and I'm going to add 12 protons, because I had no choice but to add those 12 protons here, but now I've got to balance them with 12 protons here. Now if I were in acidic medium, I'd be done now, but I'm in basic medium, so there's an extra step. When you counterbalance hydrogen with H+, you have to go in and add an equal number of OH-. So if I added 12H+, I now have to add 12 OH-, but I have to add it to both sides. So I've now got to add 12 OH- to both sides. It's important that you do it to both sides. The side of your reaction that has the H+ and OH- in equal amount, we're going to simplify our lives a bit, and we're going to relabel that as just water molecules. So it was 12, remember the number 12, but instead of separate ions, we can just condense it to 12 water molecules. Okay, let's go ahead and check the mass off, because we've balanced the mass of half equation A. There are no oxygens in half equation B, so there's no need to add water, and therefore there's no need to add protons. So our mass is already good for half equation B. So don't just go through the routine of adding water unless there's oxygen. There's no need otherwise. Now we want to double check the charge last. It doesn't have to be equal. It doesn't have to be 0. It has to be equal. Okay, so I have 12 negative charges on the reactant side, but only 2 negative charges on the product side. I can only add electrons. So if I've got 12 here and I've got 2 here, I must add 10 more electrons to give me an equal number of negative charge on both sides. So 10 negatives plus 2 negatives is 12, and that balances the 12 negative over here. So the charge is balanced. 2 negatives as a product, so I need 2 negatives as a reactant. Notice, if you know in one half equation you have electrons as a product, you a priori know you have electrons as a reactant, because the electrons have to be on opposite sides of the arrow. Okay, so we've got 2 balanced half equations, but the electrons won't cancel when I add them together. I've got 2 and 10. 2 and 10 both factor into 10, so I just need to scale half equation B by 5. So then I'll have 10 electrons and 10 electrons. So just for good record keeping, let's go ahead and rewrite what we have. We've got 6 water molecules and Br2 and 12 hydroxides. Then I've got 10 electrons and 5 Br2s here. So I've got 1, 2, 3, 4, 5 objects. 1, 2, 3, 4, 5 objects. Then the arrow. Then I've got 2 bromates, BrO3 minus, and 12 water, and 10 electrons. And then I've got 5 multiplied by 2, which is 10 bromides. Okay, 1, 2, 3, 4 objects, 1, 2, 3, 4 objects. Now I cancel spectators, and I always begin with the electrons. Never ever have electrons in your final presented answer. Electrons go, that's great. I have water common to both sides. I have 6 water as a reactant, 12 water as a product, so I can subtract 6 water from both sides, and I'm left with net 6 as a product. I don't have any bromate as a reactant, and I don't have any bromide as a reactant, so I've cancelled everything I can. Now let's just go, and I already have coefficient 1, so I can't reduce down in the coefficient rank. So let's just rewrite. So we've got Br2 and 12 hydroxides and 5. Well, I've got 5 Br2, so that's just 6 Br2, right? I don't need to write them separately. So these, you can just pull those together. I've got 6 Br2, 12 hydroxides, and that gives 2 bromates and 6 water and 10 bromides. We want to go ahead and check the mass and the charge that we have. So I've got 6 multiplied by 2 is 12 BRs. I've got 2 BRs here and then another 10 BRs here. That's 12 total. I've got 12 oxygen. 2 multiplied by 3 is 6 oxygen, plus a further 6 is 12 oxygen. I've got 12 hydrogen. 6 multiplied by 2 is 12 hydrogen. So all of my mass balances. And now finally charge. I've got 12 negative charges on the reactant side. 10 negatives plus an extra 2 negatives is 12 negative charges on the product side. So again, we just had that extra step in basic medium where as soon as we counterbalanced oxygen with water and then we further counterbalanced the hydrogen with proton, we had to add an equal number of proton to both sides, and then the side with protons and hydroxide we condensed into X amount of water, and then everything was the same. This is going to be a crucial little step in our progression towards electrochemistry topics. For example, electrochemical cells that we'll see further on in this content chapter. And this will conclude this video.